So 9 o'clock batch, am I audible, every one of you?
Yes,
every one of you, am I audible?
Yes.
Yes,
Okay.
Harsha.
So just please stay connected a minute, please. Okay. The previous batch has got a bit delayed. They just now left. And we'll come back here to the 627. So we'll continue with our discussion where we had left yesterday. So yesterday we had left our discussion at inheritance concept. So what did we discuss yesterday? Let's try to recollect for first 5 minutes. So yesterday's session is entirely understanding the concept of encapsulation, class, inheritance. It's a universal thing, not only related to Pega. Plus one more thing is getting the architecture details about our application classes. So when you create a new application, some number of classes have been created automatically. We are just making an observation and trying to understand what classes are created there. So what do you call those classes? What level of classes are being created? And what is the purpose of the classes? So in our application, when we look at, okay, first let me tell you. Class means it's a group of attributes plus functional components. Anything you want to create, you create inside a class. That classes will be there inside an application. The classes will be there inside an application. This is first point. Second point is inheritance. Inheritance is a parent and child relationship defined between two classes where the child class can access any of the attributes and functional components of the parent directly. Vice versa is not possible. So one child accessing the data of one parent, which is a higher parent always higher level, one parent immediately, that is called single level inheritance. So this can be even multi-level. What do you mean by multi-level? Means grandparent, parent, child, even great grand is also possible. So child can access the features of parent as well as child can access the features of grandparent. Grandparent also possible. That is just like a chain. That is just like a chain of connectivity. Like in our family, we are getting our property since our forefathers, right? So great grandfather, since long back, property is being given to the next level, like that it is coming. How it works in real life, the same way technology is being designed. So why do we need inheritance? Inheritance, the purpose of having inheritance in your application is the common features, instead of creating at multiple places, you create at the one place at the higher level called parent, access into all children. Create once, access into many places. Okay, easy to extend, reusability, all that you can achieve by the concept of inheritance. That's why your system should follow the inheritance concept. Then you can achieve much better reusability. You are ignoring inheritance and proceeding means you cannot achieve reusability. Okay, we will follow that. Okay, and here you go now. After the discussion of inheritance is over, we have logged into our implementation application. What is our implementation application? Please tell me. Yeah, what is that? Name of star, right? Star heart. Okay, devimpl@hart.com. And we have logged into implementation application, and we have just made an observation by going to the Dev Studio App Explorer. What are the classes that are loading there? So what classes are loading, you know? Tell me, what are the classes loading? HART-IMPL-work. These are the three classes that are getting loaded when you go to Dev Studio. We are just trying to understand the architecture details. That's why I went there. Okay. And App Explorer, here you go. HART-IMPL work. Clear, everyone? So this is organization level class. When you compare with the organization structure, this class is organization level class. And the middle one is said to be implementation application class, because the name of the implementation application, I mean like ID, name means ID, application ID of the implementation application, and this class will match. This is application class for implementation. And this work class is said to be class group or transaction class or it can be said as work class. So this is unit level class. When you compare with organization, what is this one? Unit level. Middle one is division level. Organization class, application class, class group or work class, and organization class, division level, and unit level. Unit level is the one where your actual business transactions gets initiated. That's what we discussed already yesterday. So we can understand from that point, work is the class where transaction can be initiated and processed. Okay, above two levels will supply common features to below levels. You have only one level, you can have even multiple levels of trees, but I did not create anything as of now. Now, for framework application to see, you have logged into framework application, went to Dev Studio, App Explorer, you are able to see the framework application transaction class. But from here also you can see framework application classes. To see, you don't have to log into framework. You can see from here, Heart, FW, you will be able to see that. Heart FW, this is what we have seen when we log into framework application. You don't have to log in. You can see from implementation also. But yesterday I have logged in and shown you. From here you can see. So for framework application, you are getting one additional level of class, FW, in a sense to give you an idea that this is related to framework application. Pega provides this as read-only, not allowing you to modify. I've shown you where it will provide in the advanced configuration. Correct? Everyone, that's what we have discussed yesterday. So for framework and implementation, both places, you will get work class. In framework application, you got work class. In implementation application, you got work class, which means that in a framework application, under the work class, if you create your transaction model by creating a flow and execute it, you will be able to execute or not? You will be able to execute. First point. Second, we are just going to come to today's session. Now, implementation application also one work class is there. For every application that you create, Pega by default giving you one class group, that is transaction class, where you can create flow, execute flow. But I will ask you one general question. Try to tell me, are we going to create any flows which are we going to execute any flows in the framework application to initiate our transaction processing? Are we going to do any such thing? Yes or no? Just think it with a common sense. Implementation application, you have a facility to execute a flow to make a transaction, to create a transaction. In framework application also, they provide a facility where you create a flow, execute and make a transaction, initiate a transaction. Now my question is, of course, you create a flow in framework application and all. Suppose you have created reusable flows and all. But are you really going to execute a flow in the framework application work class to initiate your insurance transactions? Yes or no?
No.
No, Harsha.
No. Why no? What is the reason for no? You can tell me now.
Because it will
Because
happen.
transaction happening in implementation work class.
Transaction should happen through implementations. That's the point. I told you yesterday one example. On a road, you can walk on left side, right side. But the system defines certain things which you need to follow. Disobeying is up to you. But if you disobey, you will not match with others. The entire world is one side, you are another side. Right? There can be a problem. Your application doesn't fit in the real world. So they provide a facility where you can execute to make a transactions, but you don't do it as a developer. Because framework application, you are going to use it to create reusable components, which you want to access into your implementations at runtime. Okay, like that you have to use it. In real time, everyone will use like that. So as a system, it will give you certain guidelines, but not restrict you from doing many times. Understand? Got the example of road left side, right side, right? Same way. So the systems will give you guidelines to be followed, worldwide developers, which you should follow. Sometimes as a system, it won't restrict you. Sometimes. Some other times it may restrict. Okay, just keep this in mind. Let's now go and discuss about rest of the things. What is that? We're going to discuss. See here. Today, so we're going to talk about OOTB classes in Pega. See, Pega rules process commander environment has so many predefined functionalities. So out of which one I have shown you on day one, send email, notification. Send email notification is a OOTP functional component which is already available in Pega. In which application? Pega platform application. But it should be available in a class, no? In which class it is available? Base class. Base class. Pega platform application has thousands of predefined classes. Okay, how many classes are there? You have that question, I will tell you. Just you don't bother about what am I doing. Okay, how many classes are there in entire OOTB? So per page 40, for example. Per page how many? 40. How many pages are there? 120. 40 into 128 you calculate. At least 40 into 100, 4,000. Those many OOTB classes are there in Pega. Those many classes are there. Okay. So those many OOTB classes are there in Pega. But how Pega will create these classes? Similar to us. See, our application has levels of classes, no top level, one are. For entire our business application, only one top class is there. What is that? HART, organization class, is the topmost class for our application. For Pega platform application, what is the topmost class? That
Base
question
class.
you may get now. Base class. Base class. 1 point. So under this only every other levels of classes will come. Many levels will be there. Now I'm talking about the second level. Second level, what are the classes available by name? What components are there inside class? I'm not telling. So many components will be there which you will be reusing, simply speaking. Work dash, data dash, int dash, index dash, embed dash, code dash, rule dash, what else? Assign dash, what else we have? Assign dash,
History.
history dash, perfect. Good. History dash, etc. 14 topmost classes will be there. Usually how many? Second level 14 will be there. And third level many will be there. Okay, now see here. This is very topmost. These are the second level of classes. Means these are all children of base class. These are all. See, your classes are also children of base class. In Pega, every class is ultimately a child of base class. Ultimately a child of base class. Second level class are children of base class for sure. Why the class names itself have dash? You can explore to find any class in Pega through this search bar. Search one. Work. Work is not there. Work dash is there. This is OOTB class provided by Pega. This has so many classes. This has so many classes. Under the work class, you will see one more class. Under work class, you'll see one more class under work dash. Next level, I am writing work dash, cover dash. Work dash, folder dash, work dash, channel dash. Like this, you'll find so many. Okay, so many things you'll find. We are not concerned about all the classes. So like this, Pega has so many classes. All the predefined functionalities are available in OOTB classes that are available in OOTB application Pega platform. Okay. Now, we want to reuse the OOTB functionalities provided in Pega platform applications, OOTB classes, into our applications. Do we need to do that or not? You want to do that or not? So if you want to access the features of OOTB classes of OOTB application into your application classes, what relation should be defined between the classes? Inheritance relation should be defined. Okay. How to define that? That's one question. Okay. We'll come to that point now. So before we talk about how to access by inheritance, we will discuss about abstract and concrete classes. Then I will give you understanding about why dash is there in the class name. That also I will tell you. So are you clear so far? Just these names, you don't need to buy hard. Okay. Some OOTB classes are there in Pega platform application. That point, if you're able to grasp, that is pretty much fair enough. Clear, everyone? I'll go to the next topic called types of classes. All are connected. That's why I'm taking half and going back and coming back forward like that. See, the technology has two types of classes. Classes are being segregated into two types, two categories. One is abstract, second one is concrete. One is abstract and second one is concrete. Generally, if you remove the word abstract and if you remove the word concrete, what is remaining? Class is remaining. Means class is a class whether it is abstract or concrete. What does a class contains? Class contains attributes plus functional components, functionalities. Okay, will be there. Attributes plus functionalities will be there. Again, here also you have attributes plus functionalities will be there. Now, what is the difference between abstract and concrete? Concrete class means transaction can be initiated. Transaction can be initiated. Abstract class means you have everything okay class. In this class, transaction cannot be initiated. See, you know what? You have one abstract class, one concrete class. If you create a flow, you can create a flow in both classes. Classes can have anything created. You can create a flow. You create one flow in abstract class. You create one flow in concrete class. Execute the flow in concrete class. It will be executed. It will initiate the transaction. Try to execute the flow of abstract. It says one message. I cannot initiate transaction, something like that. Transaction cannot be initiated. Instances cannot be written to the table, something like that. It will show. Means you cannot initiate a transaction. So after segregating classes into two types, they have applied one restriction on abstract type. What is the applied restriction? This class cannot initiate transaction. This class cannot initiate transaction. Clear everyone? Online students, are you clear? Respond on the charting window and unmute and respond. Everyone should respond.
Yes.
Yes, Harsha.
Yes, sir.
Right?
Yes,
Now
Harsha.
I have one question. Just think about it. Why the technology has segregated classes like this to have abstract? See, if you closely look at it, abstract class is a subset of concrete class. Yes or no? Abstract is
For sure.
subset of concrete or not? Subset means
Yes.
whatever is there in concrete, if you take some part of it, that is abstract. Yes or no? So why abstract class is there? What is the reason? The technology has provided a facility, create some class as abstract, create some as concrete. I will tell you. For this to understand, you go back to the example which we have seen yesterday. See, the students who are attending today as their first day of Pega class, you may not be able to understand it 100% properly because it is purely connected to yesterday's session. Okay, up to some extent only you will be able to understand. Yesterday video, today's video, combinedly you watch one after other, you will be able to understand 100% much better. Okay, now that's just a information to you. Come back to this example. Here you have account department, loan department, card department, and verification department. So in real life, you think about real life. There is a building called bank. In that 4 rooms are there. Each room is going to do some specific task of account processing, loan processing, card processing, verification. So verification department is a common need. Verification department. I'll copy this to bottom. Verification department is a common need. Is a common need for loans, cards, loans, account department. So verification department usually will go at what level? Parent level. Usually it should go at what level? Parent level in the inheritance. Okay, very good. Is there any way you initiate loan transaction or card transaction or account opening transaction in the verification department? Deposit, withdraw. So in the real world, should the verification department have any such ability of initiating a business transaction processing? Should it have any such thing?
No.
No.
Any such ability? Should not have.
No.
So in my real world business setup, I have one department where it doesn't have any authority to initiate any transaction. So show me in the technology, such feature you should also bring it in the technology. So initially they created only class, no abstract, no concrete. In the class, they are able to do transactions. They created a verification class, execute transaction is happening. Now business is asking, if you execute transaction in the verification, should not be executable. Provide such a facility in your technology. Now they have segregated classes into 2. Abstract, when you execute to make a transaction, not executable. Concrete, when you execute to make a transaction, executable. Now, real world business structure you need to take in a document. Start creating each department as a class. The departments which can initiate transaction, create them as concrete classes. The departments which are not allowed to create any transaction, create them as abstract classes in your application. Really, business people, do they know abstract and concrete to give you in the requirement? They don't know. They don't know abstract concrete. What they know, this department, they do this particular task. they cannot initiate any transaction. Like that, they will write in the requirement. This department, they can initiate the transaction and they will have some functionalities. That's how they will give. All this they will give at the very beginning of the project. Very beginning of the project, you are going to go with this particular setup. Correct? Yes or no? So based on that architecture, you will set up your application classes here. This is the reason why abstract classes exist in the real world technology. So in the real world technology, why classes are being segregated into two? In order to match with the real world business entities. Real world business entities. Technology should always have the capabilities to match with the reality. If not matching, problem. Okay. Makes sense? Everyone understand abstract and concrete classes?
Yes, Harsha.
So usually abstract classes will be parent classes. Usually means it's not mandatory to be always. Concrete also can be parent, no problem. No problem. Can be parent, but usually in your application structure, higher levels are always supplying things. Lower levels are executable things. Lower levels are executable. At the very bottom, execution will happen. So that's why organization division are non-executable abstracts. Unit is concrete. Now what we do is, I will go with one document and I will give you the document, observation document I'll give you. So now abstract and concrete classes. If you don't make this observation and proceed further with business requirements also, you'll be able to develop something. But better to have the clear idea. Okay, now let's log into our IMPL and FW apps, have an observation. Just observation means what? Already it is done. You are just making an observation to know what is already present in the system. Have an observation to know about what type of classes created by new application wizard. This observation we are going to make only to the classes of class group of each application. Class group of each application. Class group means what? Work class. Each application that is loading, no? When you go to Dev Studio, click on App Explorer, 3 classes, 4 classes loading. Only those things we'll observe. Remaining we don't observe. So remaining is not, this is not right time to think about. 627, right? So this is an observation thing. Okay, because you should know before you start working on practicals. Let's go there now. I'm sorry. What is our application, sir? HRT, this one only, right? Okay, here you go now. Implementation application you have logged in. So now these are 3 classes, no? These are 3 classes loaded. So now access to see the definition of a class. To see the definition of a class, we need to follow the below navigation. Okay, follow below navigation. One time only I'll write. Right click on class. Right click on class name. Then do what? Then definition. What do you mean by that? Definition. Definition means details. It will show the details. Look at here now. How would I access organization class here? 3 classes are only loading, no? So it is very simple. Place your cursor here. Backspace it up to organization by removing the dash. Click on enter. It will load all the classes. We are not focusing on all. HART. Here you see leaf icon is there, no? Beside class. Beside name here, leaf icon is there, means that is class. Symbol to know that is a class is leaf icon. Okay, this is a class, this is a class, this is a class, this is a class, this is a class. We are not focusing on all other. We are focusing on this one, this one. This is framework related. Framework related also getting shown in implementation. It will be usually shown or not? It will be shown because your implementation is created on top of framework. If you create separately, is it going to show? No. Now I will go to HART, right click on HART, definition. I am not giving any information like backspace. You need to do it. Backspace part, you know. Backspace to go up to there. Definition, it will open the definition. What type of class is created at the organization level by Pega? So organization class, HART is abstract class. If you would have manually created, you should do the same thing. You would have done the same thing, yes or no? So suppose you are not depending on there is no process of manual creation anyhow. Suppose there is no wizard. If you manually create class, top level, what class you would have created? Abstract only. Definitely. Now second level class will be. What is the second level class name? See, display name ID. Two things I told you. Display name ID. Which is important? ID. So display name is top level class. HARP is ID. Good. Display name is HARP IMPL. Right click on this and see the definition. See the definition. Okay. Its name is not HART IMPL. ID. ID is not standalone ID. It is been concatenated to the previous class with a hyphen. This plays a key role while discussing about inheritance in Pega. Just have a look at it. So type of the class is HART IMPL. HART IMPL type is also abstract. What is your guess about work class? Work, third one, expand this, you will find work. You'll find work. Right click on this definition.
Class.
So work class is a class where we initiate the transaction. You see, this is a concrete class and its name is not work standalone as it displays here. Displaying work only, but its ID is work is been concatenated to previous three classes. So work class is work class. I'm sorry, I have to give a screenshot of that, right? Work class is concrete class where we can initiate the transaction. Clear, everyone? Now the IDs of three classes. IDs of three classes are as below. First one is HARP, organization class. Second one, HART IMPL. Third one, this is how you need to read. This is how you need to, you should not read this any class here standalone. Second class, while you are reading, read with previous class name hyphen second class. So hyphen you generally call here as dash. So now this is what just an observation that we have made. Let's go to the concept of inheritance in Pega. So now how Pega has inheritance being implemented. So in Pega, we have a need. In Pega, we have a need that suppose similarly, if you look at framework application classes, HART is common class for framework implementation, abstract app. FW abstract, HART, FW abstract, and then work is concrete. Work is concrete there. That work is HART, FW, FW work. Means FW application I'll write down. Give me 1 minute. FW application, simply I am writing. What classes will be there in FW application? HART, FW, HART, FW dash, HART, FW, and work. Okay, give me 1 minute. This is what it is. This is, what is this one? Abstract. What about this one?
Abstract.
This one?
Abstract.
This one you guess and tell me?
Concrete.
Concrete. Clear? See, this is what we have got. See, we have a need now. In Pega, we have a need that our FW application classes should be able to access the features of Pega platform classes. Pega platform classes. Our FW class, our FW application classes should be yes or no. This is required or not? If it is not required, then why to use Pega? Next, our implementation application classes should be able to access the features of FW application classes and Pega platform classes. These are the two things. Apart from this, implementation application work class, implementation application. Okay, I'll do one thing. I'll make it as first point. Our implementation work class should be able to access, the features of work class means class group. Okay. Work class means what? Class group. Work class or class group. Technically definition I will tell you later. So you can understand, as of now, you can understand work class or class group is a class where transaction gets initiated. That's what you can understand. IMPL application work class or class group should be able to access the features of organization and division. Division here is application class. Yes or no? All this is much needed. All these 3 points should be achieved. That is what we are going to discuss in the next topic of inheritance in Pega. Okay, clear everyone? These 3 should be achievable. When these 3 are achievable, then our application setup is perfect. We are okay to proceed creating functional components at some places and access it ultimately at the. So every component you create anywhere in Pega, ultimately it will be accessible at work class level at runtime. At runtime, it should be accessible to work class level. See, in Pega, work class is just like what is that? You see, it's a kind of origin. It's a kind of origin. Just like I'll tell you, you have solar system. In solar system, you have many planets. But what is the origin? What is the origin solar system? Sun is the
Sun.
origin. If you want to say about any class, any planet, you say about the planet with respect to sun. Yes or no? Same way, you talk about any class in Pega, always you talk with respect to your transaction. Transaction class is origin. From there only everything will be accessed. Everything should be accessible ultimately at the, that is the origin. Okay, understand? Just keep that in mind in general point. Now coming back to this one. So your implementation work class should be able to access the features of higher classes, should also be able to access the features of framework class group plus Pega platform. So your implementation class group, where is it? Your implementation work class or class group should be able to access the features of organization division classes of current implementation application, IMPL. So organization division are part of IMPL application, no? Common means organization is there for this. So within IMPL application, organization division are there. That should be accessible to implementation work class. So next, I'll change this point order. Okay, this order I'll change. Second thing is our implementation application work class or class group should be able to access the features of framework application work class or class group. Work class or class group. Okay, this is one thing. Separately I'll write. And third point I'm changing. Our framework application work class or class group should be able to access the features of the Pega platform classes, some class, whatever it is, Pega platform. This is what we would like to achieve. Now coming back to this one. How our implementation application work class can access the features of organization and division which belongs to same application. How it can access? Only when there is inheritance relation defined, right? Only when there is inheritance relation defined. That is already defined. That is already there. How it is there, you can see here. So I am now once again I am going to show you. When HART is created, go to definition of HART. Standalone. Before this class, do you have any other class before HART in the ID? This is a topmost class. And when HART IMPL is created by Wizard, it is been created concatenated to the previous class. Example, I will show you. Manually, I am showing, don't bother about navigations. It's not the navigations you need to think about. You need to only understand the concept for now. So I am creating a class after HART. After HART, Wizard, whatever has done, I am manually trying to do it. I am trying to create a class. Class name is test. What is the name of the class? How I am creating class? I'm not standalone creating. I'm giving a hyphen after HART and creating. Okay. Test label and name both are same. Okay. Some details I will provide. Simply I am saving this by filling the fields. Options I am filling. And so class is created now. Test class is created. Should it be there or not there? It should be there, no? See whether it is there or not. After HART, a class by name test is there. Yes or no? Just backspace and see. Test is there. You open the test and see its definition. Its ID has test created concatenated to previous. Means whenever a class is created, it is connected to previous class by hyphen. That hyphen represent inheritance. A class inheritance represented by hyphen in the class naming convention is a pattern defined. Is a pattern defined. That's why it is called as pattern inheritance. This is called as pattern inheritance. This inheritance is defined by class naming pattern. By class naming pattern using what? So how do you read this? Dash, not hyphen, dash. You read it as using naming pattern. This inheritance is defined by class naming pattern using dash, So to the current class, the previous classes that occurs before the dash are parent classes. Example is A dash, B dash, C. Here in this, okay, for B, the parent is, okay, the pattern parent. What is that? Pattern parent is A. Oh, I'm sorry. For C, the pattern parents are B and A. This is multi-level. You understand now? Your multi-level, universally multi-level, and here multi-level, you are able to match, yes or no? So are you clear, everyone? So now in Pega PRPC, there are two inheritances. One is pattern, another one is direct. Why we need pattern inheritance? Question. Why we need pattern inheritance in Pega? To access the rules means components, the rules of higher classes. Higher means in a tree level, you'll see higher class. Higher classes into lower classes of same application. We need pattern inheritance. We need pattern inheritance in Pega. Why we need? To access the rules of higher classes into lower classes, where these classes are of same application. See, it is as simple as our real life. See, how do you get the property? How, without earning, you are getting property, right? How are you getting property without earning? Because your father is giving you. How your father is also getting some property without earning? Of course, you have your own earnings. That's a different case. Okay. So without earning also, you are getting some property inherited from your parent, your father. How your father is getting? Grandfather is getting from great grandfather. He is getting from forefathers above levels. Yes or no? All these are connected. All these people are connected by blood relation. So is it within one family or other family also will come in this chain? Of course, other family will not come in this chain. Other family has their own chain, right? So this pattern connection of blood relation is happening within the family like this top level, correct? Exactly same. Family means one application. Within application, current bottom level to higher level, you see how many classes are there? All these are connected by dash. That is blood relation. This is pattern. Pattern inheritance means you get the features only from the higher classes of same application. Other applications will not come into higher level. Of course, HAT is common class, means it is there in the current application. Okay, that's an exceptional situation. It is there in the current application also. So If you want to access other application class features, those will not come in the pattern inheritance relation. Definitely those will not come in the pattern inheritance. As simple as the people from other family will not be seen in the blood relation structure from bottom to the top level in your family. Same way. Are you clear with this point, everyone? So you can remember when someone says pattern inheritance, you can remember the real life example of blood relation in a family. Okay. So the very bottom level, whoever is living now, parents, 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 all are related. How blood relation. So pattern inheritance is just an example of blood relation in the family. Clear, everyone? Are you clear, everyone? Every one of you. Pattern inheritance, you understand? So the purpose is very, very important to understand. It's not pattern inheritance is naming pattern. Okay. Why we need it? To access the features of higher classes into lower classes where the classes of same application. Yes, please. Someone was trying to ask something. Then when pattern inheritance cannot give you accessibility of other application classes, how to access other application. Here, when I say other application, that must be a built-on application. That must be a, how can we access the rules of built-on application classes into our application classes? That can be achieved by using second type of inheritance. That is direct inheritance. To access the rules of built-on application. Rules means functionalities. Built-on application classes into current application, we need direct inheritance. We need direct inheritance. So how do you get the property without earning from another family? Just like a simple example. Don't take it too seriously. Simple example. Suppose there is a guy. He is getting a property from his father. Okay, forefathers by pattern, blood relation. So now he got married. In India, how it works? He got married to a girl from another family. So through that, he is able to access some property from another family. No? This is a direct relation of marriage made between two people, right? So this direct relation is said to be direct inheritance. Another application. Definitely those are connected. Yes or no? So pattern inheritance means blood relation. Direct inheritance means marriage relation. You can remember these two things to remember this one. Definitely you are getting property from another family only. No? That's how you're getting. So now direct inheritance means here you are going to access the features of classes of another application into your application classes. That other application here is what? It must be built on application. Applications connected. Then only you can access the connected application classes features. Otherwise, you cannot access. See, two applications separately created. You cannot establish inheritance relation between the classes of two different applications where there is no relation between applications. So I'll write down that point here. So we can define direct inheritance relation between the classes of two applications only when one application is built on application for other application. If two are separate, see, on Pega platform, you created one application. On Pega platform itself, you created one more application. Application A on top of Pega platform. So application A can access Pega platform features by direct inheritance. Application B on top of Pega platform. Application B can access the features of Pega platform classes when you define direct inheritance. But application B cannot access application A features. You cannot even define the inheritance relation because these are separate. When can you define inheritance relation? Only when you create one on top of. Understand why we need to create one on top of another to be able to define direct inheritance relation. So now where do you define that? Pattern inheritance you have seen in the class name itself. Where do you see direct inheritance relation defined between the classes of current application with the classes of built-on application? That's the point we are going to see now. Are you clear, everyone, so far? Are you able to follow or not? Everyone?
Yes, sir.
Yes, sir.
You're able to follow, right?
Yes,
okay,
sir.
just follow me now. So now, okay, I will write down here. So where can we define direct inheritance parent of a class. Where can we define? So this can be done. This can be done in the class definition. In the class definition at the section. Which section? Parent class.
Parent
Direct.
class.
Parent class directive. That place is there. I'll show you. You know what? This I will show you. For our implementation application, for our IMPL app work class, for our IMPL and FW app work classes, the direct inheritance parents are already been defined by wizard. Let's make an observation. After we make observation, if everything is okay, we'll proceed further with our requirements. Something is not matching means we'll make a change. Something will not match. That's why I told that point. See here now. So let's look at that. First, I will go with implementation, application, class group definition. See, let me tell you one point here. When we talk about the direct inheritance, I am only focusing on the class group of implementation application and the class group of framework application. I am not going to focus on division classes and organization classes for direct inheritance as of now. You also don't focus on that because you'll get confused. Don't focus on the direct parents of these classes. Leave it. Only focus on two classes: implementation application transaction class, framework application transaction. I will draw this as a diagram. Okay. So implementation application class definition I'm going through. Okay. Definition. In the definition, scroll down. When you scroll down, you can see this is where you can see this checkbox. I will tell you after 1.5 months, not now. So parent class, this is what you do. So what is the class chosen here? Parent class work dash power dash. I'll remove this and I'll give something else and save. Try to save. Is it accepting? What is the error message you got? Means system has some restriction here. A class group means a transaction class must inherit from work dash OOTB class. Work dash is what? OOTB class. I forgot to tell you one point. Before a class name dash is there means that is abstract class. See, before Pega 6.2 means 6.1 and before. No, 7 version. Before Pega 7 version, 6 is there, 5 there. After 7, 5, 6, okay. 4, 5, 6, 7, 8, 23, 24. These are the versions, major versions. 4, 5, 6, 7, 8, 23, 24. Today 24. I will teach you that. From Pega up to Pega 6. Up to Pega 6 version, when you create a class, the class name tells the process commander whether it is abstract or concrete. In the class name itself, hyphen is there. Name itself, see. Work dash. Work dash, you cannot separate. Dash is not separate. Work dash is class name. That is abstract. The system will treat that as abstract. In a class name, dash is not there. After the class name, dash is not given. That is concrete. But Pega later changed it. From Pega 7, they provided an option. By option, the process commander will identify whether it is abstract or concrete, not by dash. But old classes, no, at the very Pega beginning, they have created these classes, no. Still, the naming convention is there. So why the class names work dash, data dash, int dash, index dash? Why these class names itself have dash? Because these are abstract classes. In the old versions of Pega, abstract classes will have dash in the name. That is still followed. I mean, like carry forwarded to upgrades. Keep that point aside. Come back to here. So now your implementation class group. See, a transaction class must always be derived from a transaction class. That is what? That is class group. That is what? Class group or your work class must always inherit from, must always directly inherit from where? Work dash or child classes of work dash. See, that is a restriction in Pega. If you create any transaction class, it must derive from work dash. So deriving from the child class of work dash is also fine. How come? Why it is fine? Because it is deriving from its child. It is inheriting from the child. See, A, B are there. B is child. C is inheriting. C must inherit from A. That's what I told. But C is inheriting from B. Is that okay or not?
Okay.
That means ultimately C is also inheriting from A, no? That's the reason you got the message saying that subclasses. Make sense clear, everyone? So I'll put it back to what was there. I'll refresh it so that it will come back. Because I did not save now. It will come back to the old one. This is how it was. So I'll draw one diagram now. So what is already there, I am drawing as a diagram. Okay, if required, we'll make changes. So I'm going to draw this as a diagram. Here you go now. This is work dash cover dash. Work dash cover dash is OOTB class or not? Work dash cover dash is OOTB class, which is child of work dash. Which is child of. So our class group inheriting from child of work dash is fine. That means it is inheriting from work dash only. Now here you go. One more box here. This is implementation class group. This is implementation. So your implementation class group is inheriting from the framework class group, means it can access the features of framework class group. Yes or no? It can access the features of framework class group. This is what that arrow mark is inheritance relation. This is what type of inheritance? Direct inheritance. This is direct inheritance. Direct inheritance diagram. What is already present by default, whatever we got, I'm teaching you the same. Direct inheritance 627. 627 and saving the diagram. This is for implementation you have experience to see. Let's look at framework. I'm not going to bother about divisions and organization. To see framework application class group definition, should I log into framework application class group?
No.
Let's observe the same thing for FW application class group. We can access from here itself. You don't need to log in there. Just backspace here and type FW. It will show there. Somehow it will show in the list. You select from the list. Okay. Now right click on this definition. This is also inheriting from. This is also inheriting from what? Work dash. Work dash. Cover dash. Let me draw the diagram now. So this is FW application class group, transaction class. And what about this one? This is implementation application class group. Understand? And the inheritance what you are experiencing by default Pega provided when we create a new application by using Wizard is this. So from the diagram, what we can say is implementation applications class group can access the rules of Pega platforms, work dash, cover dash class. That is much needed. This is much needed. What is the second one you can say? Framework applications class, FW. Okay, this is also much needed. But one more thing is needed. What is the other one needed? But we need implementation applications class group should also be able to access. The rules of what?
FW. Yes.
FW applications class. But this is not happening, no. By default, what is provided by Wizard can give you 1 and 2 points, whatever. Third point also needed, much needed. That's why we designed to create one on top of another. But that is not being possible, that you can see in the diagram. Now we need to make changes to achieve this. Now to achieve this, we need to make some changes. With that, we'll wind up for today. We need to make some changes. You don't have to tell me technically where to make the changes in the PRPC environment, but diagrammatically, you tell me. Diagrammatically, what has to be changed?
Another arrow in between IMPL and FW.
You need to add one arrow between IMPL and FW. I am adding one arrow. I'm adding one arrow between IMPL and FW, and I have added it. So from this, for IMPL class group, there are two parents mentioned. What are the two parents mentioned? I'm sorry, I'm writing reverse now. There are two parents mentioned. So for IMPL, now it has two parents being mentioned in the direct inheritance. What are you doing? You know, you are going to the definition of implementation application. You are taking from implementation application as work dash cover dash comma. This is what you are trying to do. By the diagram, what is being drawn now, additionally, this is what you are trying to do. Yes or no? Save this. Is it getting saved? It is not allowing two parents. Direct inheritance, you must mention only one parent. Two parents mentioning is not okay. Then diagrammatically, you tell me the change now. Additionally, what should I do? After adding arrow mark, whatever you told, arrow mark part is correct. I added as per you. Tell me what else has to be done. Online students.
Remove the arrow from work cover to IMPL.
Remove the arrow from work dash cover dash to IMPL. Remove. Oh, what is going on? Remove. Where is it? This one. I want to increase the size of this eraser. Remove the arrow which is there in work dash cover dash to where? IMPL class. I removed it as you told. Is this okay now or not? You just tell me. So from this diagram, let's make the change diagrammatically. First, let's make the change diagrammatically. So diagrammatically, whatever you have changed, let's try to understand this. From this framework application class group can access the features of OOTP work dash cover dash. Good, very good. Implementation application class group can access the features of framework application class group. That's what we wanted to actually achieve. Okay, whatever you want to achieve, being achievable. But one more thing should be achievable, no? Implementation application class group should also be able to access the features of Pega platforms work dash cover dash. Is that being achievable from the current diagram? Yes or no?
Yes.
It is
Yes.
being achievable.
Yes,
How?
it is being achieved
Like this.
through
We can
framework.
here to here.
Yeah.
Understand clear? Everyone? This is parent of parent is parent. Here in the direct inheritance, you can see multi-levels. Direct inheritance, you can see multi-levels. So parent of parent. So from this, we can achieve whatever we wanted to achieve. Now this change we have to make in our implementation class group definition. Class group definition. Implementation class group definition. Go to implementation class group definition. Okay, just let me put it back to the original state. How it was before. This is how it was before now. Implementation class group definition. Remove work dash cover dash and choose what? FW application class group. So this is one thing Pega Wizard is not able to provide us. We are manually setting right the structure. Okay, remove this. So in Pega environment, if you see a text box with a thick blue color dot at the right bottom corner, that is drop down. Place your cursor here, click the down arrow and you type H. H will be highlighted. There you see work class. There you see what? Work class. Understand clear everyone? So I'm sorry, what are you seeing there? Framework related work. Okay, framework related work class. You see, select that. Save. We are done. Saveable or not? See, class group should inherit from work dash, but it is not inheriting from work dash. It is inheriting from framework class group, which is inheriting from work dash. That is okay. Subclass is also. This is the only change you need to make in order to set right everything good as of now. There are few other things we need to correct. I'll tell you that. So inheritance point. So now there is a question now. So if you look at, there is a question now. In interview, they are asking you. In Pega, we have two types of inheritance, pattern and direct. Interview are only saying. In Pega, we have two types of inheritance, pattern and direct. Now he is questioning you. Why Pega has come up with two types of inheritance? What is the reason to have two types of inheritance? What you should answer is, so Pega uses pattern inheritance in order to access the higher classes functionalities into lower classes of same application. That's the purpose. And in order to access the Pega platform features into current application, Pega will use direct inheritance. That's why Pega has two types of inheritance. Okay, everyone clear? That's how you need to answer. Every one of you clear?
Yes, Harsha.
So that's how they may ask you one question. Now, another point I'll tell you. Look at here. If you look at implementation class group, work class, for work class, it has a parent class immediately available in the pattern inheritance. Also, it has one more parent in the direct inheritance. So a class is inheriting from another class through pattern. A class C is inheriting from A through pattern, B through direct. Suppose means at a time for one class, two parents are there in Pega. Yes or no? This is called multiple inheritance in object-oriented programming language. In object-oriented programming languages, achieving multiple inheritance for a class having multiple parents is not possible by classes. In technology, it is not possible, but that has been made possible in Pega through classes itself. A class is having two parents at a time, one through pattern, one through direct. This is how Pega achieved multiple inheritance here. Multiple inheritance. This is called as dual inheritance. What is it called in Pega? Duo means two only, not 3, 4. So for a given class, there is a pattern parent, there is a direct parent. Duo, two parents are there. This is called as dual inheritance. Many people, they don't know this. In interviews, they may not ask you. So what is dual inheritance in Pega? Question. What is dual inheritance? A class having two parents, one is in the pattern and the other one is in the direct, inheritance. Then that is called dual inheritance. Suppose if you look at the class HART class, does it have any pattern parent? Does it have any parent in the pattern? Before HART, any class is there. So HART may have direct parent. HART may have direct parent. You see the definition. Don't bother about it. What is there? Why it is there? Something is there in the direct parent. Means it has direct parent, but it doesn't have pattern because it is topmost for our application. This is only single inheritance. This is not dual. So for our class group, you have dual inheritance. That is what it has. Pattern parent at the same time, direct parent. This is additional question that I am going to post here. Done. So you will get interview questions related stuff, everything tomorrow, not today. You will get tomorrow. And tomorrow is the last day as a free sessions for anyone. Today, I'm sorry. Today is the last day as a free session for anyone. From tomorrow, only the students who are completed their fees payments allowed. Offline also, strictly that you need to follow. Okay. Suppose tomorrow you want to come down to the class, make the fees payment and come down into the class. Everyone. And otherwise, you need to wait and take your decision. Okay. Online students, anyhow, the meeting link will change now. Maybe after an hour, only the students who have completed their fees payment and enrolled, they will be receiving the meeting link. Okay. Clear everyone? Others will not be able to connect to the classes from tomorrow because the meeting links will be shared, will be changed and will not be shared with, will be shared only with enrolled students. Please complete as of today at any cost. Okay, because we have given enough time for everyone. So that's it from my end. See, these concepts and all, as a beginner, you cannot grasp everything in a day. Now itself, if you go back and sit and study, you cannot remember and fully you cannot understand. As you start experiencing Pega day by day, automatically you'll understand. When you revise in future, you'll understand. While I'm teaching, I'm sure that you understand it. Okay. But once you go back and sit and study with this document, you'll get a lot of confusion. Okay. This concept, I request you to understand only. Pattern inheritance means class name. Direct inheritance means class definition. Follow this document. Make this change in your application also. Save it. Don't go through this document at all.
Sorry, can you come again that point, Harsha? Whatever you said right now.
Yes.
Direct and pattern. That is very catchy.
Yes.
Can you
what you need to get from today's session, 1 hour session, is just in your mind, pattern inheritance means having the parent class before the current class with hyphen. Done. Direct inheritance means in a class definition, we'll choose some class as direct parent. Done. And the practical change I have done now, direct parent, this you do and keep it aside. Throw away this document. Don't see it now. You start doing practicals, right? When you start doing practicals, slowly you'll be able to realize to understand pattern direct much better. You'll get a good grip on that. And later you can revise this document. You'll understand much better. Okay, once you start exploring PRPC ready-made features and you access how you are accessing through direct inheritance, that's what you can go and cross-check this document later. So while explaining, it will take a lot of time, but the grasping points will be very few. Actually, this session is 5-minute session only. Overall, how long it is going to be? 5 minutes only. Pattern inheritance, class naming pattern, A-B-C. A is parent of B, B is parent of C. Pattern inheritance by name. Done. Direct inheritance. In the class definition, you specify a class as direct parent, direct inheritance. Class can access the features of pattern as well as direct. Pattern inheritance is to access higher level classes to lower level of same application. Direct inheritance is to access built on application classes into current application classes. Over. Concept is over. That's it. That's what I want to tell you. But with a clear-cut explanation and with so many questions being posted during the session, I have taken 1 hour time to explain. But for you to learn, actually, it is just 5 to 10 minutes. So, and one request to every one of you is, do not unmute while the session is going on. If you unmute, please mute it back. Otherwise, it will disturb others also in the meeting. Okay, I have muted from my end. And one more request is, I request you to make an observation of the direct parents of implementation class group and framework class group. These two only. Do not go to organization class, division classes, and direct inheritance, and do not try to analyze those things. You will get confused a lot. So strictly be away from analyzing the direct parents of organization, division, FW classes. Only work classes of each application you analyze and try to experience what we have discussed today. Okay, clear everyone? So only that part you need to do. Okay. So
Harsha,
we'll
can I
continue.
ask a question?
Yes, go ahead, please.
When we opened and see the class definition, there was a field where there's a drop down and it's mentioned belongs to a class, is a class group. So and it is a drop down, so it gets 3 things. So is it
Yes, you are
depending on the developer to choose, or like how is it, how that works?
See here, this is what you are asking about, right? This is a separate session.
Yes. Okay.
I'll explain you this later. As of now, I did not even tell about class group technically. What you understand, class group means, okay, we can initiate transaction there. In that particular class, we can initiate. What about the other options? What about this option? You will come to know soon, very soon. I'll take those as a separate session.
Thank you.
For now, technically, I did not explain you class group, but you understand that, okay, class group is a place where we can initiate a transaction. That's it. Okay, technically, I'll tell you. So I'm going to share this document, and in an hour or two, you will be receiving a message saying that meeting link has been changed and shared with only the students who have enrolled for this course, and others will not be receiving that. And if you have to finish the fees payment, do it last minute. See, I'll tell you one thing now. Tomorrow morning, 8 o'clock, 7 o'clock, if you do, our team will not be available to share you the new meeting link. By today, end of day 6 p.m., you finish that so that someone will be available to share you. Tomorrow, 8 o'clock, if you make the fees payment, or 8:30 a.m. if you make the fees payment, in a hurry, no one will be available to give you the meeting link. Anyhow, tomorrow, 8 o'clock, 8:30, if you pay also, you'll miss the class for sure. So that's why I'm telling you, please do it at any cost today, max. Otherwise, wait for 1 day and do it. And they will give you the link after you do it, and recorded video. Anyhow, they'll be sharing after you enroll for the course. So with a delay, you can watch on Saturday or Sunday. That's up to you.
Harsha, I have one more
close the
doubt.
meeting. Yes, please go ahead.
Yeah, actually, in dual inheritance, can a child class have two parent classes, like 2 pattern or 2 direct? Like you said, 1 pattern and 1 direct.
Anyhow, pattern sequence will be there. Parent of parent will be there. Parent of parent, but class cannot have like this 2 patterns. Not possible at all. Okay.
2 direct also.
2 direct also, directly not possible. Parent of parent is possible. I have already shown you, na, comma, another class, not possible, obviously.
Okay. Okay, Harsha. Thank you.
Okay,
Harsha, I'll have one question.
go ahead.
Basically, like suppose if we call with a parent class with both inheritance, direct as well as pattern inheritance. So which one get a first preference once we got
Priority
figure out?
wise, I will tell you later. Reason I will tell you later. As you are asking, I'm going to tell you. Suppose a class has pattern direct both. From whom I should take? Your father, mother. Both have money. From whom you want to take? First, that's a question here. So two parents are there. From which parent I should take? Pega is designed in such a way that by default, the first priority to pattern. Okay. Second priority to direct. Pattern is not having that direct parental. Okay. So that's how Pega is designed. With reason, I will explain you after some time. Okay. Why it like that and all reason I will tell you.
And one second question, Harsha.
Yes.
You told me some base classes we have, right?
Hmm.
So basically, suppose in implementation classes, so we have one rule which is defined on implementation class only, and inside that rule we are calling one. We want to call one OOTB base rule. So it is necessary to like define like we can call this rule inside the base rule only, or we need to define to the like we need to change the class for this base rule, or we can directly call to the base rule only.
See, in implementation class, if you want to call a rule from base class, okay, your implementation class is inheriting from some OOTB class, right? Definitely your classes in the direct inheritance, ultimately it will inherit from some OOTB class, usually work dash. That is already child of base. So you don't have to make any change. Anything you want to access from base class into anywhere in Pega, you can directly access. Okay, because already direct inheritance parent, whatever is there, that's already a child of base class. Ultimately, that is a child of base. Every class available in Pega is child of base class. Next.
Okay, for ideal practice, so we should change the name, right? In framework, like for this OTB, like we
No
not
need to change
necessary.
anything. You
Okay.
can directly access.
Okay.
If you want to customize something, already provided one, you can change the name if you want to change. That is also there is some criteria whether to change or not. No need to change the name.
And Harsha, one more thing.
You learn that soon. Yes.
So that today changes for our application will be only this changing the inheritance, right?
Only that is a change. Remaining
Yeah.
all just an observation.
Okay.
Observation, understanding. Finally, coming to a conclusion, what to make change. Just a simple 1 minute task. Practical is 1 minute only today. Next.
Harsha, later you will be relating it with the organization and division unit.
You will come to know, slowly you'll understand. Now itself, if I tell
Okay.
no, you will get confused a lot. We'll slowly see where is organization going to get from, divisions are going to get from. You can see. Because too much of theory will create a lot of confusion. Okay, one direction you understand enough. Remaining directions also same way. Okay, we can still slowly explore those things. Next, any other questions? Okay, if you're good to go ahead. So I'm going to close the meeting. We'll continue tomorrow. Thank you for joining.